You are welcome to Industrial Excellence Center by R. Lakshmanan. In this presentation, let us see lean practices from concept to implementation. A brief note about me. I have personally implemented manufacturing excellence practices right from 5S up to WCM, that is world class manufacturing. And my experience goes with multiple industries, tire industry, auto component industry, and footwear. We all know small improvements get us big results. And lean practices is one of the best suited practice to achieve that. Managing the workplace through lean concept is a mindset to eliminate waste and deliver value to the customer. At the end of this presentation, we will have clear understanding on what is lean management, what are all the benefits we'll get, what to focus during the journey of lean implementation, what are all the underlying principles in lean implementation, that is steps to implement lean, what are all the waste involved. It is popularly known as 3Ms. Details of it we'll see later. There are 7 waste. With human resource added to it, it becomes 8 waste, and we need to understand very clearly to implement lean. To implement lean, there are many technical tools. We need to understand what are all the tools, what kind of tools to be used to implement lean. And these are the topics which we'll be covering during this presentation. What is lean manufacturing? Lean manufacturing focuses to reduce all those unwanted processes, all those non-value adding processes on the existing products. That is, it focuses to reduce processes that don't bring value to the product, that don't add value to the product. If the process is not adding value to the product, it is of no use. Why at all it should be there? It is only adding the cost. Therefore, it has to be eliminated. So, lean manufacturing focuses to reduce all those non-value added activities. This has been initially used by Toyota, and therefore it is called as Toyota Production System. It is also known as just-in-time, that is JIT. By bringing inventory and storing in our location for long is also a non-value added item. JIT focuses on that. Therefore, JIT is also a part of lean manufacturing. Through lean implementation, the organization gets a lot of improvements. I have listed here at the left side significant improvements only. There are much more. As we get these improvements, it also results in real benefits that is given at the right side. What are the significant improvements? We said lean removes, eliminates all those unnecessary activities, non-value adding activities. That is, it removes all waste, which means automatically it improves productivity, it enhances the existing production capacity, it reduces the response time to the customer. Therefore, we get goodwill of the customer. Therefore, we get more orders also. Since all waste are removed from the process, automatically will be highly cost efficient manufacturing plant. As a result of all these significant improvements, we get 3 major benefits, core benefits. 1, maximize the value for the customer, which means for the money what customer is paying, we give much better service to him, much better product to him. So maximizes the value to the customer, and it reduces or eliminates the waste in all forms. Whatever waste is there in the company, it gets addressed in this lean. Therefore, entire waste is getting eliminated or at least reduced. More than that, most importantly, continuous improvement culture is seeded among the team members. This is the, according to me, this is the most important benefit any company can get. Once this continuous improvement culture is there among the team members, there is no end to improvement. Improvement keeps on coming, and therefore it becomes a big long journey. There is no end to it. Therefore, this is the most important benefit which any company can get. During the process of lean implementation, what are we supposed to focus? It is all forms of waste. Yes, anything which is not adding value onto the product is called as waste, and during implementation of lean we are supposed to eliminate all such wasteful activities. Eliminating such wasteful activities gets us significant improvements which we have seen. Therefore, the main focus is to reduce all types of waste. Eliminate the waste wherever possible. Where not possible, at least minimize it. We have now come to principles, underlying principles of lean. That is, these are the steps to implement lean. There are 5 major principles. 1, identify value. 2nd, value stream mapping. 3rd, creating a flow. 4th, establishing pull system. And 5th, seeking constant improvement. Let's see the details of this in subsequent slides. We are now seeing the first principle, the first step to implement lean. It is identify value. Identify the product value. Identify the real value. What is this? It is everything that the customer desires, paying for the product. That is, customer is willing to pay for the product. He need not pay for additional inefficient activities which we are having at our home. So therefore, it becomes very important to identify this real value. Why we should do this? While we do it, when we are doing this, we will be able to see a lot of non-value added activities, non-value added features. So therefore, to do this activity, we need to have very close discussion with customers to understand what their real requirement is, what is their real need is. Understanding their real need, we need to map our processes, our product, and arrive at the correct value. At the end of this, we'll be able to understand what are all the non-value added activities. Let us now see the second step, second principle, value stream mapping. It is popularly known as VSM, and it is the most important step to implement lean. We will have multiple processes to manufacture any product. Each process will have its own value. Some processes will add value to the product. Some processes will not add value to the product, but it will add cost to the product. Value is different, cost is different. So through this value stream mapping, we will be able to identify the real value added by the processes onto the product. At the end of it, we will be able to identify which are all the processes adding real value, which are all the processes which are not adding the value but adding the cost. So we can identify value adding and non-value adding processes. We need to understand this concept in depth so as to practice it right. It's a big subject on its own. Through subsequent slides, I will make the concept very clear so that you will be able to practice this back at your home. Before understanding as to how we can make VSM, there are certain important points associated with it which we should understand. First, let us understand what is VSM. Value stream mapping. Value in stream, value in flow, and that is mapped. So, any process, any product will have multiple processes. Every process will have its own value. If you arrange all the processes in sequence in the flow pattern with its own value associated with it, then it becomes value flow for that product, and that is value stream mapping. Whereas in process flow chart, same way we show the flow of processes, but we don't show the value. Okay, why we should show this value there? What is the benefit of VSM? When we see the entire all processes for the given product in entirety in a single look, we'll be able to easily understand with our background which process is really strong, which is weak. That is, some process would have already matured. There will not be any scope to improve further. That is strong process. There are some processes which are very weak. There are a lot of scope for improvement, which are called as weak processes. So we can find out the opportunities to improve such areas. One. Second, there are multiple areas where we get the opportunities for improvement. What we can do? We can also identify which process will be having highest impact. Which one should be focused first? So that also we can get from this chart. Third, most important, we need to shut mouth of many people now. Some people will keep on telling, my process is matured. There is no scope. You come and see. These are all the words will come from any manufacturing setup. We all know that. This chart will show the real scope available. If it is matured, fine, it is matured. Or at least we will be able to understand if at all the process is matured well through this VSM. Now, to implement lean, this VSM along with 5S practices forms a basic foundation. These two are most important for implementing lean. We have already published a video as how to implement 5S step by step. Those of you who want to understand that in full can visit that video. Now, let us understand how to make VSM. Now, let us see who can make this VSM. Can an individual make this? No. It has to be done by a team, by a collaborative team. See, any product will have multiple processes. Every process will have some nitty-gritties. Only the process owner will know and will have the complete knowledge of the process. Therefore, it becomes necessary to form a team for it, and that team should be a collaborative team. The team should also have reasonably good knowledge about product as well as process. The team should also have some knowledge about 5S practices. What do you mean by value add? What is non-value add? Other practices like SMED, etc., etc. These are the tools which are required for implementing lean. We need to select carefully what are the tools that is required depending upon the product line and the company. These are all given at the end of the presentation. Let's see the details when we go there. Now let us see how to make VSM chart. Normally, VSM charts are made for any product line from start to end. Start means even supplier end is covered. End means until it reaches the customer. However, for example purpose, for understanding purpose, I have given here only two processes. Also, there are certain specific symbols normally used while making VSM. Some of those symbols I used here, not all, because this is only for the purpose is to explain the concept. Now, material is stored either in WIP form or in raw material form. From there, material is drawn to the first process, shown as process 1. During this step, these materials are waiting. You can see a triangle symbol with I. And waiting for how many days? I is inventory. Waiting for how many days? 5 days. X quantity. X quantity is required to make, you can see process 1, that batch size, 500 units. This process is designed so as to make a minimum of 500. So this X quantity will be as a balancing quantity. That is most important. Okay. Now, the 5 days it is waiting. What is the purpose? There is no purpose. It is not adding any value. We have to understand this concept. Then it goes to process 1. There are some vital data information I have given here. These are all hypothetical value. HC, head count, number of people, 2. CT, cycle time, 5 minutes. PT, process time, 1 minute. CO, changeover time, 15 minutes. REL, reliability of the equipment of the process, 95%. FTP quality, more than 98%. Means, as we produce, it is right. No touch required. So first time, right. And batch size is 500 units. Now, small observation here. Cycle time is 5 minutes. PT is only 1 minute. So 4 minutes extra, which means there can be some scope here for improvement. Someone has to raise this question. From the team, as we observe this chart, someone has to raise this question. From here it goes second process, where inventory is waiting for 1 day. Now you have to understand whether inventory waiting here 1 day is right or wrong. There are sometimes the inventory waiting is important. There may be process specification itself. If it is as per the specification 1 day, it is okay. If it is exceeding the specification, then 1 day is more not required. So it is also becoming non-value added. So we need to understand such points and raise questions. Now in process 2, you see cycle time shown as 10 minutes, process time shown as 1 minute. So there is a big difference. So there can be a good opportunity. So probably the team discussed here and they arrived at an opportunity for improvement. So they came with an idea. That idea results into the Kaizen. It is called as Kaizen burst. So such Kaizens are locked and implemented, followed. Like this, it keeps on going on until the product comes to the finishing stage. Now, for any product, when we look at this in one full sheet, like this, we can understand where all the scope is there. Simply list all the scopes. Don't miss out anything. Then as a team, each and every scope, go into details, raise questions, discuss, then arrive at some solution. Thereby you can list out all the opportunities that is available. From these opportunities, we can prioritize whichever is most impactful, give first priority, and then start implementing it. So this is how we make a value stream mapping. This is sample. Normally, if a value stream mapping has been done for a product, it will be a big board. Even a conference room has to be allocated for a plant. Let's say that. When we are doing this kind of lean practices, it is important to have consistent follow-up. Maybe we can have some consistent meeting, maybe once in 3-4 days, or once a week, or once in 2 weeks, depending upon the products, so that none of these Kaizens or lose the importance. We should not be lost. The energy which we have put in making value stream mapping and arriving at the scope, opportunities for improvement should not go as waste. Therefore, consistent follow-up is very, very important. As we are making VSM chart, in the previous slide we said there will be a lot of opportunities which we can see directly. So we need to capture those opportunities. So there are some structured way to handle this. In subsequent slides, we are going to see 7 forms or 8 forms of waste. We need to raise a lot of questions to reduce or eliminate such waste. From that angle, the question should raise. Some examples I have given here so that based on this, one can make a good questionnaire so as to capture all opportunities that is available through VSM. Certain questions are: is there any inventory pile-up? Is there a repeated material movement? Can the process be made more visual? Can the process be automated? Is a customer in a shop floor next to process is the customer? Communicated well for a seamless operation, because he should know how much is the production done, how much is the right quantity, how much is the rejected quantity. There should be some board available. Where is the material available? He should not be running here and there for want of details. Any process is there any process duplication or process getting repeated? Such things. So how is production scheduled? During the production schedule plan, whether machine capacity, lead time, etc. has been considered well. If it is not considered well, automatically there will be a loss. So such questions, by raising such questions at each and every process, by seeing the data, we can arrive at the scope that is available there. We have seen how to make VSM. The VSM made for the current process with the all required vital data is actually a current state of VSM. It depicts, it shows the actual condition of the current process and what are the scopes that is available there. Now, we may be wanting to make our process to a future level. That's called as future state. This future state, there are two methods. One can make a similar VSM for a product, design the process, what are the right process that is required, eliminating the waste, make the process. This becomes future state. This is VSM. VSM future state. Now we have VSM current state. Both are available. We can compare these two and understand the gaps. To bridge the gaps, these are all opportunities. So develop Kaizens. Some of the gaps can be handled through 5S practices, and there are many other VSM tools. This is one method to go to future state. Another method, instead of making a future state hypothetically, from the current state, you can go step by step also. From the current state, identify all the opportunities, make that as the gap, eliminating that, make one more future state. That is another method. The second method, what we said, is more practical in nature. Most important here is either of the method you can follow, but what is more important, the future state should be little difficult to achieve, but it should be achievable. Then only the system will work. So accordingly, now at this stage, we have one current state of VSM and future state of VSM, and therefore we have lot of opportunities which is evolved as either Kaizens or 5S practices or many other procedural policies also. So we need to identify all these things, implement, without any fail and adherence to this implementation is very, very important. Now let us see principle 3, the third principle, the third step in implementing lean. It is creating a flow. In second step, we saw VSM. In VSM, we identify non-value adding activities. As a team, we have also taken some steps to eliminate them. Now we are left with only value adding activities. Arrange these activities in a sequential manner so as to have smooth flow of material from one process to the next process until the material is smoothly delivered to the end customer. It is very important to have smooth material flow for a smooth production process, efficient production process. How to ensure this? This can be ensured through a technical display board called as Kanban board. This Kanban board practice will help us to ensure smooth material flow from one process to next process. Let us see the Kanban board practice in the next slide. I have shown here a typical Kanban board for understanding purpose. You can make a suitable changes to this as per your need. Only one caution, this board should be as simple as possible. If it is simple, it will communicate better and also people will follow. If it is complicated, we all know, we tend to violate. But if the board is violated, it will disturb the production plan badly. There will not be smooth material flow from one process to another process. Therefore, this board is important. Second, without this board, one cannot imagine implementing lean. Therefore, this board is very important. Okay. What is this Kanban board? Kanban board shows the production status and storage status. Simple. Let us say process 1 team have to produce material and transfer to process 2 team, which means process 2 team is the customer of process 1 team. So process 1 team produces components required for process 2, that is shown here as A, B, C, D, E. So how much they have to produce? There may be some backlog that is shown in the next column, and there will be some today's plan also that is shown as new plan, totaling that total quantity to be produced. Now these are the components and quantity to be produced by process 1. Can they go ahead simply produce? No. They need to understand the priority demand requirement of process 2. They are the customer. So based on their need, they need to show the priority. Here it is shown component A2, component B1, like that. In other words, the priority is fixed based on the stock that is available in the storage racks. Number 1. Number 2, sometimes priority can also be changed based on the end customer demand. So based on that, what is more important is we need to fix the priority. So once the priority is also fixed, it is now ready for the process 1 team. They can go ahead do production based on the priority. As they produce it, they need to also display the status of the production. Is the material totally ready, or is it under inspection, like that? You can see here pending to do, under production, under test inspection, and done ready for use, like that they have to give the status. Also, most importantly, the material storage location. Like for component A, it is stored in rack B in level 2 in cell 3. You can have some storage identification like this. This identification is very, very important for the team 2, that is process 2, who are the customer of process 1, to come and see on their own, understand, verify whether the production is going on as per their demand, how they can take. So there will be smooth material flow. To ensure smooth material flow, this kind of Kanban board is very, very important. Now this color, what I have shown here, yellow, green, blue and all that, one can use colored tokens also or tags. Anyway, based on your need, convenience, you can use it. Now, with respect to this status board, in case the storage location is little away from the production location, there should be one more board available near the storage. So storage location should have its own display board showing the material available, quantity, status of that material available and where it is stored, so that it makes the process communication from one to another easily. Thereby we can ensure material flow from one process to another process very smoothly, and that is creating flow. We have to ensure smooth material flow from one process to another process. Let us see fourth principle, establishing pull, rather fourth step. What is this pull? Normally, how we have been producing traditionally, let us say there are two sections, section A, section B. Section A has to produce components and give it to section B. Let's say section A has to produce component X and component Y to B. Normally what they will do, section A will see what the component they have. They don't have component X, they have only Y. So they will produce Y and they will dump on to next section, section B. Whereas section B will not be able to use it, because there is no need for it. Because they had some other problems. They don't have to use it now. So it will be waiting there. So the material what is produced by A, section A, is not of any use for section B. Rather, it is going to simply stay idle in the rack. It is sleeping in the rack. This kind of pushing the material, I produce and give it on you. This kind of pushing is called as push system in production. This will accumulate a lot of wastages, create a lot of production disturbances. Thereby, operation will be most inefficient one. Wastages will not be there, will get accumulated. Whereas what is lean? We have to eliminate waste. So which will not happen through this push type of production system. We have to now convert it into pull type if we have to implement lean. How to convert this into pull? Now you see what is pull. Subsequent section, that is section B, pulls the material from section A. If they pull the material from section A, now section A will understand section B is pulling the material from me, therefore now I have to produce this. That is, section A will produce only the material what section B needs, or what is the demand of B, only that kind of material section A will produce. How to implement this? This can be implemented. In the previous section we have seen Kanban board. While we are planning the Kanban board, when we are giving priority, there are two things in the Kanban board. One is the planned quantity, second one is the priority. You see the storage rack of subsequent section. In this case, it is section B. If the rack material is full, you don't have to produce because they don't need it. They had some other issue. In section B, there are some issue. Therefore, they have not withdrawn the material. They have not pulled the material. As section B has not pulled the material, rack is full. Therefore, section A should not start producing that item. So, this pull system can be easily established through disciplined practice of Kanban board. Simply follow Kanban board without any hesitation, without any violation. Then you will be able to implement pull easily. Most important. As we are producing only the material what is required for the subsequent section, that is customer, and also we don't produce more material in stock. We are producing for production. We are not producing to stock. This will help us to increase the efficiency and improve cycle time and throughput time also. Thereby, wastage is reduced. Automatically, lean also gets its way on. Most importantly, follow Kanban board practice to ensure full system. We have now come to fifth principle, fifth step, seeking constant improvement. Through the previous four steps, more or less we have implemented lean. If it is done across the entire organization, yes, it is really done. But doing lean once is not of any use unless it is maintained. We need to maintain this. How do we maintain? Through PDCA approach or through daily standing meetings. There should be some continuous follow-up. As we keep on following up, what happens? We also keep finding out new ideas. All those ideas we need to list down and keep on taking action. As we do this, this continuous improvement culture will go into the minds of the people, and every day they will think, what is there today? What is there today? Something like that they will keep on doing, and this, if the continuous improvement culture is seated into the minds of the people, there is no end. Improvement keeps on coming, and the journey will keep on continuing. So far, we have seen how to implement lean. What is lean? Elimination of non-value adding activities. What are those non-value adding activities? They are waste. So we should have clear understanding on what are waste. Unless we have clear understanding on waste, we will not be able to act upon that. So there are how many types of waste are there? There are three types, major types. There are three types: Muda, Mura, Muri. These are all Japanese words. No need to worry. We are going to see the explanation in subsequent slides. This is also very popularly known as 3Ms. 3Ms, Muda, Mura, Muri. These are the ways to be addressed, to be eliminated, or at least reduced to implement lean. Out of 3Ms, the first M is Muda. What is Muda? Any activity that does not add value to the customer is a waste, and it is Muda. There are 7 types of waste. It is necessary to eliminate all these waste through our continuous improvement approach. Nowadays, the number of waste are not 7, it is 8, including human potential. There are a lot of skills which we cannot ignore. To list out all these 8 types of waste, number 1, overproduction. Number 2, inventory. Number 3, motion. Number 4, defects. Number 5, overprocessing. Number 6, waiting. Number 7, transport. And finally, number 8, our own employees' human potential skill set which our employees and suppliers have. We will see the details of all these things in subsequent slides. The first waste is overproduction. What is overproduction? Whatever quantity we produce in excess of the demand is overproduction. That quantity is not going to be used immediately. It is going to go into storage racks only. It only adds into additional cost in terms of transportation, resources, waiting time, and rework. How rework? Some of the components, some of the materials, if it is stored for long, will lose its characteristics and therefore results into rework or sometimes even scrap. The second waste is inventory. Normal inventory, what is required for the operation, there is no problem. If it is stored more, it unnecessarily increases storage cost, does not add any value to the customer. It can be raw material, or it can be finished goods, or it can be anything. Excess of inventory adds cost but adds no value to the customer. The third Muda wastage is motion. required movement of man material is okay. Anything which is not required, which is unnecessarily we are doing, then it is a waste. It eats away our production time. Therefore, efficiency will be less. Sometimes it adds to safety hazard also. So it is necessary to eliminate all those unnecessary movement of material and people to have efficient operation. This will help us to reduce the cost as well as implement lean smoothly. Now, why this unnecessary movements happens? It can be due to poor ergonomics. That is, the workstation is not designed properly considering the man and material movement. It can happen. Second, the process sequence, material flow sequence. We have seen creating material flow. We have to create the flow perfectly. If it is not done well for some XYZ reason in the design stage itself, then this will have unnecessary movements, which is not adding to the value. Third, poor machine layouts. For maybe with respect to machine size or space availability, for some XYZ reason, the machine has not been laid properly. Layout itself forces us to have unnecessary movements. So we need to address all these things quickly to implement lean effectively. The fourth loss, fourth wastage, the MUDA is defects. We all know whatever we produce 100% is not right. There are some defects, poor quality, sometimes entire things also scrap. All this will lead to additional cost and it does not add any value to the customer. Whichever is not adding value to the customer has to be addressed quickly. The fifth MUDA is over processing. Over processing means additional cost. What is over processing? Just for understanding purpose, let's take the example of a process industry where we need to make a compound with, let us say, 5 chemicals. All the 5 chemicals are mixed together. We need to have more uniformity, consistency, homogeneous. So what we do normally, first time mixing will not make it to more uniform. So we mix second time, we mix third time, we mix fourth time. Let us say, for example, second time itself, uniformity, that consistency has been achieved. In that case, mixing third time, fourth time is unnecessary. It is over processing. So mixing third time or fourth time adds to the cost. Why should the customer pay for that cost? So we should avoid over processing by strict testing controls. The next waste is waiting. Man can wait for want of material or machine breakdown. Machine can wait for want of material and man, whatever it is. If there is a waiting of man and machine, it is a big loss, which means there is no smooth material flow. There is no smooth production process flow. If there is no smooth production process, there is always a loss. It can have even quality loss. Now, why this kind of things happens? It can be due to machine breakdown. It can be due to setup changes. It can be due to waiting for approvals. Approval itself will take time. They'll be waiting for hours together. Sometimes WB material would have been produced, but it has not been tested and cleared. So many things like this. There are so many reasons why waiting happens. Waiting of machine, waiting of man. The subsequent process may be waiting for the material from the previous process. So we need to address all these root causes of waiting, because these things are adding to the cost, but it does not add any value to the customer. The seventh waste, seventh MUDA is transport. Unnecessary movement of raw material, work in progress or finished goods. Always this excessive movement, unnecessary movement will sometimes it can affect quality also. Some materials moving for long distance will have impact. It increases the cost transportation cost will be more. Does not add any value, but increases the cost. How to control this? Normally, from start until the end, the material movement distance is added, and we take target for this, finding out the unnecessary movement, and we take target and reduce the distance moved. From start till the end, material movement distance should be tracked and controlled to overcome this loss, transportation loss. This cannot be eliminated fully, but it can be definitely minimized. We need to optimize, either eliminate or optimize. Okay. The eighth loss, most important. Many problems can be easily solved with our own employees' talents and skill sets. Sometimes the suppliers can give us lot of ideas to solve many issues. Most of our issues, problems, defects can be solved with our own internal potential. Unfortunately, we don't respect them, we don't recognize them. This is also a big loss for any organization. So one has to have a clear understanding on this. We have earlier seen first M, Muda, and its 8 different types of waste. Now this is the second M, Mura. What is Mura? It is a situation where uneven, irregular production happens. The process is not even. If the production line has got, let us say, 5-6 stations, all the stations are not uniformly loaded. It is not uniformly balanced. It is very difficult to balance everything uniform, but it can be balanced very close to uniform. If it is not done, unnecessarily there will be loss. Sometimes this uniformity cannot happen with respect to shifts and days also. Some days the production planning we do in such a way, some days will be plan will be very high, or most of the complicated items will come one day. All simple items will come another day. In some shifts it will be overloaded, some shifts it will be underloaded. We have to be very clearly looking into these things to avoid inefficiency. This kind of uneven, irregular load, imbalance will create inefficiency, and therefore loss will be there. This can be addressed through line balancing. Third M, it is Muri. What is Muri? Overburdening. Overburdening of man, machine, material. Let's say an equipment has been designed to produce 1000 units a day. We load beyond that 1100 units. Machine is overloaded. Suppose the machine has to run to produce the 1100 units. If a machine has been running normally, let's say 500 RPM, now it has to run at maybe 550 RPM. So you are overloading the machine. You are running the machine beyond its capacity. So it will lose its capacity quickly. It will show in wear and tear, and it will break up. This overloading of machine, example. Same way, excessive stress on man, unreasonable targets, poor ergonomics. It's very important, poor ergonomics. If the workstation has not been designed well considering the man and material movement, the efficiency will be totally lost. Poor, inefficiency only. We will not get the designed output because the man loses its energy quickly. Therefore, we will lose out on unnecessary movements only. It will not result into useful output. If it has to be, unless these kind of situations are avoided during the design stage itself, we will not have better output and quality will not be good. It will get deteriorated. During when we start seeing the gaps, the current state of VSM and future state of VSM, all these points to be addressed. Take this as the gap, opportunity for improvement, and address this to implement lean and get the benefit. For implementing lean, we need to have knowledge of certain technical tools which are required to eliminate waste and to implement various ideas which will come across, which will get for changing the current state of VSM to future state of VSM. I have listed out all those technical tools here. It is not that all the tools to be used. Depending upon your requirement, you can select the required tools from here and use it. Before starting lean, try to have good knowledge on these technical tools. The first one is Kanban, which we already explained during the process of lean implementation slides. Second one is Kaizen. I am sure you will be already having knowledge on Kaizen. Value stream mapping. This also we already explained during the second step. The fourth tool is 5S. On 5S implementation, we have already published a detailed step-by-step implementation system in another video. Those of you who want to have good knowledge on 5S, you may visit that. The fifth one is PDCA approach. Sixth one is production line balancing. The seventh tool is automation. If there are some fault that is happening, immediately that machine or that line stops so that the operator, the concerned person, takes the immediate action. This will help us to control the quality. The eighth one is Pokayoke. I am sure all of you will have the knowledge on this. Ninth one is standardize the way of working. This is very important. For simple understanding, I am telling you, there are two machines. In one machine, first button is on, second button is off, third button is forward, fourth button is reverse. Example. If the same sequence is not followed in the second machine, then by chance if you are interchanging the operator for some XY reason, then the operator will get confused. Therefore, standardize the way of working is very important across the entire industry. The 10th one is on dawn, alarm we say. There is a line. The specification, the process is going beyond the control. Let's say there is a process specification 7 plus minus 0.2 kg per square centimeter. While it is running, the process is going out of control, out of this limit. That should be some indication for immediate action. So that is this alarm control. The 11th one is SMED, single minute exchange of die. This also I am sure all of you will have knowledge on this. The next one is Six Sigma method. This is also one of the efficient method to implement lean. But I would advise you to have very good knowledge on 7QC tools, which are very simple tools to follow, and more than 95% of your problems can be answered to 7QC tools. The next one is visuals, most important. More controls if you have visual, very easy to communicate, and it will be effectively handled by the operators very easily. Therefore, as much as possible, implement visual controls across the industry. Finally, with all these technical tools, it is not sufficient. Most important is daily shop floor walk, Gemba walk. Walk through the shop, observe, understand, raise questions, keeping waste elimination in the mind. This will help us to do a lot. This will get us a very big result. Any missing in Gemba walk, slowly the system will dilute. This is the one which helps us to keep the system on. Therefore, it's very important to have Gemba walk. So as I said already, it is not that all these technical tools to be used. Select what is required for your component, for your industry, accordingly use this. So we have seen what is lean, how to implement lean, what are the waste that is associated with this, and how to eliminate these waste. There are systematic methods to implement elimination of these waste. We have seen most importantly VSM, Kanban along with 5S has to be necessarily used to implement lean successfully. Along with this, little bit of good knowledge on these technical tools will definitely make you succeed in implementing lean. Lean becomes real only through people and practice. The journey does not end with implementation, but it begins, because lean is not a one-time project. It is a practice to be followed. It is a way of life to be followed forever. The only continuous journey gets us good benefit. I'm sure you'll be able to implement lean with your collaborative team, not by individual, but with the team. Thank you for watching. You may contact me for any clarifications.